Welcome to this depth dive. I'm truly delighted to be here with our expert who's joined us in the studio today. We're going to unpack a really pivotal piece of writing.
Great to be here.
Today, we're taking a close look at an editorial published in the journal Clean Technologies and Environmental Policy.
That's right. It's a piece that really digs into the huge challenges, but also the smart strategies for achieving sustainable and, importantly, equitable decarbonization globally.
Absolutely. So, our mission today is to kind of cut through that complexity, pull out the key insights. This stuff is so important.
It really is crucial and complex, as you say.
So, get ready because we hope you'll see this topic from some surprising new angles. Okay, let's get into it. The editorial kicks off by making that direct link, doesn't it, between fossil fuel emissions and global warming?
It does straight away. It frames this as the driver for what it calls unprecedented efforts to reduce carbon intensity.
Unprecedented efforts, and it highlights this big intention. Shifting the whole global energy system away from carbon towards renewables, setting tough carbon targets.
Yeah, it really sets the stage for just how enormous this challenge is.
So it's not just a quick fix.
Not at all. And what I found fascinating is how they frame this transition. It's not just about technology, although that's huge. They call it a journey.
A journey. I like that framing.
And the timeline for that journey, they say, isn't just about, inventing the next solar panel. It depends on climate goals, yes, but also geopolitics, macroeconomic effects, and really profound socioeconomic issues.
So how different societies and economies adapt globally?
Exactly. And they point to the energy industry itself, obviously the most carbon intensive, as the workhorse of change.
Workhorse. That makes sense given its role.
It's foundational to everything, right?
So if it's this global journey, how do we actually, measure progress? How do nations manage their emissions? The editorial seems to break it down.
Yes, it does. It tackles that question head on. How do you get a grip on this huge problem and target your efforts? It gives a really clear framework.
Okay, walk us through that.
Essentially, it says a nation's CO2 emissions from energy boil down to three main things. First, per capita GDP. How much economic output per person?
Okay, wealth, basically.
Kind of, yeah. Second, the economy's energy intensity. So how much energy do you need to produce $1 or €1 of GDP? Are you efficient or energy hungry?
Right, efficiency.
And third, the carbon intensity of the energy grid itself. How much CO2 is emitted for each unit of energy you do use? Is it coming from coal or from wind?
Got it. GDP, energy use per GDP, and CO2 per unit of energy.
Exactly. And when you multiply the last two, energy intensity and carbon intensity of energy, you get the overall carbon intensity of the economy. CO2 per dollar of GDP.
Ah, so there's an actual formula.
Yes, CO2 GDP,
Yeah.
answer GDP equals energy GDP, Koyoshi tide times CO2 energy. KW2. It sounds technical, but it gives a crystal clear target.
That is elegant. It really simplifies it down to a measurable thing, a roadmap.
Precisely.
So if that formula gives us the target, CO2 per GDP, how do we actually reduce it? What are the strategies the editorial lays out? Where do you start?
Well, the primary starting point, the first line of attack, is usually improving energy efficiency.
Makes sense.
The goal is to lower that energy per GDP ratio. Get more economic bang for less energy buck, essentially.
Do more with less.
Exactly. It's often the most straightforward, maybe the lowest hanging fruit, because using less energy automatically cuts emissions, whatever the source.
Right. So after you've maxed out efficiency, where do you go then?
The second big strategy is what they call deep electrification.
Deep electrification.
Yeah, I mean, shifting away from burning fossil fuels directly in factories, cars, heating homes, and using electricity instead. But crucially, that electricity has to come from low-carbon sources.
Solar, wind, nuclear.
Right. But here's an interesting wrinkle they point out.
Oh.
While deep electrification is vital for cutting emissions, it can actually increase the economy's overall energy intensity.
How so? That seems counterintuitive.
Because you're adding potentially massive new electricity demand to the system, even if that electricity is clean. Think of switching millions of gas boilers to electric heat pumps, for example. Overall energy use might go up.
Huh. Okay, that is complex. It shows it's not just a simple swap.
Definitely not.
So what about the emissions you can't get rid of through efficiency or switching to clean electricity? Those really tough bits.
Good question. For those hard-to-abate sectors or processes, the third approach is offsetting carbon. That involves carbon capture and utilization, CCU.
Using the captured carbon somehow?
Yeah, maybe building materials, chemicals, things like that, or carbon capture and storage, CCS, where you just bury it deep underground.
Okay, capture and use or store.
And then sort of the last resort, the final alternative mentioned is carbon dioxide reduction, or CDR, actually pulling CO2 out of the
Sending
atmosphere.
it back out.
Yes. And the editorial is very clear. This is inevitably the most expensive option.
Most expensive. That definitely catches the eye. So what does CDR actually involve, and how on earth do you choose between all these technologies, especially the pricey ones?
Well, CDR aims for what people call negative emissions. The main technologies are things like direct air capture with carbon storage, DAXCCS,
Literally vacuuming CO2 from the air.
pretty much, yeah, then storing it. There's also forestation planting trees, the classic approach, and BACCS, bioenergy with carbon capture and storage.
Bioenergy. So burning plants for energy.
Right, burning biomass, but then capturing the CO2 that's released and storing it. And how do you choose? The editorial says decisions should be guided by marginal abatement cost curves, M-key curves.
Sankey curves. Okay, break that down.
Imagine you need to cut, say, 1,000,000 tons of CO2. A MAC curve basically ranks all the different ways you could do it, from cheap stuff like insulation to moderate costs like renewables up to really expensive things like DACS. It shows you the cost per ton for each option.
Ah, so it helps you find the cheapest way to hit your target, the most bang for your buck.
Exactly. It guides you to the most cost-effective sequence of actions. Invest where it makes the most difference for the least cost first.
Got it. That makes sense. Now, we've been talking a lot about carbon technology costs, but the editorial really broadens the scope, connecting this all to the UN's Sustainable Development Goals, the SDGs.
It does, and this is so important.
Which SDGs come to the forefront, and which ones does it say we tend to overlook?
Well, obviously, when you target carbon intensity, you're hitting SDG 13, climate action, and SDG 7, affordable clean energy, is right there too. Though the editorial adds that crucial note. It's often mostly clean than affordable right now.
A very real point.
But the core message is that we must account for the under-prioritized SDGs. It's not enough to just cut carbon if we wreck everything else.
So what are some of those under-prioritized ones?
Things like water. Water intensity, especially where water is scarce. That's SDG 6, clean water and sanitation. Land use is huge, SDG 15, life on land. Think about biofuels competing with food production, which relates to SDG 2, zero hunger.
Big trade-offs there.
Massive trade-offs. And fundamentally, SDG 1, no poverty. Plus, the well-being of people in developing economies that brings in SDG 8, decent work and economic growth, and SDG 3, good health and well-being.
Wow. So it's really about a holistic view, not just engineering, but society, equity, basic needs.
Yeah, absolutely. It moves way beyond just a technical problem.
It feels like a real paradigm shift. The editorial even gives a name to the economic side of this, doesn't it?
It does. Connecting all this, they point out the SDGs are like a political blueprint for shifting mindsets. And the specific macroeconomic aspects of this whole transition have been termed sustainomics.
Sustainomics.
Yes, a term from Munising back in 2019. It helps frame the economic response needed to actually achieve these broad SDGs, and it puts huge pressure on the financial system, as the UN noted in 2021, to move money towards sustainable development.
And for policymakers, managing the economic impact sounds like walking a tightrope, this idea of a double-edged sword.
It really is. How do you handle the economic risks? On one side, policymakers have to minimize the risk of the transition itself, causing runaway prices, what the editorial labels carbon inflation.
Like the cost of carbon taxes or new green tech pushing up prices?
Exactly. But at the very same time, they have to act on climate change itself, because climate impacts like droughts, floods, heat waves, they also hammer the economy, and that's termed climate inflation.
So inflation from the solution and inflation from the problem itself if you don't act.
Precisely. It's an incredibly difficult balancing act.
Now, the editorial makes this interesting point that the transition mainly affects the fossil resources-based industries. No surprise there. But then it says they are also most fitted for the change. How does that work?
It sounds ironic, right? But the logic is based on their history and capability. These are the industries used to handling massive, capital-intensive, complex engineering projects.
They know how to build big things.
Exactly. And they've managed huge energy transitions before. Think from coal to oil, then oil to gas. The editorial points out those past shifts weren't because the old resource ran out, but because of external factors, externalities. And this transition is similar. They have the scale, the logistics, the project management experience.
That's a really insightful historical parallel. But still, the pressure now must be immense. What about stranded assets? The idea that their existing reserves or infrastructure could become
Oh,
worthless.
the pressure is definitely on.
Yes.
Sustainomics climate targets like the 2-degree C limit, they absolutely put existing oil and gas reserves at risk of being undeveloped, becoming
Hmm.
stranded. That's a real threat.
What?
The editorial also acknowledges reality. It states that new oil and gas reserves are needed to supply the increasing energy demand, while affordable large-scale energy alternatives are being developed.
So it's not an overnight switch off. We still need some fossil fuels during the transition.
That seems to be the argument. It recognizes we're in a transitional phase, and bridging fuels are likely necessary, while the massive build-out of renewables and other low-carbon tech happens.
Which explains why we still see investment in fossil fuels, even with the decarbonization push.
It's part of the explanation, yes. There's this complex dynamic. Traditionally, getting fossil fuels out was cheap, low marginal cost. But exploring for new reserves has become much more capital intensive.
More expensive to find new oil and gas.
Right. An analysis cited showed big oil companies massively increase capital spending without getting proportional cash flow back. But then, when global prices spike, like after the pandemic or during the Russia-Ukraine war, it suddenly makes those high-cost investments look attractive again.
Ah, the price signals.
Exactly. And once you've sunk billions into these huge long-term projects, it creates what they call technology resilience and potentially technology lock-in. You're incentivized to keep going down that path to recoup your investment even as climate pressures mount.
Technology lock-in, that's a powerful force.
It is.
So let's zoom out to the global stage. Nations agree climate change is happening, but they're clearly not all on the same page about the path forward. The editorial mentions Europe leading but facing frustrations. What are the big sticking points globally?
Yeah, it's a huge challenge for cooperation. Europe might be pushing ahead with rules and actions, but the editorial notes that the specificities of other economic blocs and nations frustrate policymakers' expectations.
What kind of specificities?
The two big examples are given. First, the Russia-Ukraine war starkly revealed how fragile Europe's energy strategy was, relying on both renewables and Russian gas. It even led the EU Parliament to label some gas and nuclear investments as climate-friendly, a pragmatic, if controversial, shift driven by geopolitics.
A real reality check.
Absolutely. Second, you have developing countries. Many have significant fossil fuel reserves of their own, and they're projected to be huge economic players, nearly 60% of world GDP by 2030.
And their priorities might be different.
Understandably, yes. Affordable energy, economic growth, fighting hunger, eradicating poverty, these are often top priorities. For many of them, natural gas looks like a crucial transition fuel to achieve those basic development goals first.
So it really sounds like a truly fair, truly equitable transition has to acknowledge these different starting points, different priorities, and maybe even historical responsibility.
That's exactly the point the editorial drives home very strongly. It argues it is pointless to forge reforms for which a society is not yet ready.
You can't just impose a one-size-fits-all solution.
No, it criticizes simplistic calls like, just leave carbon in the ground, because that completely ignores the liability of past emissions from the developed economies.
The historical carbon debt.
Precisely. Developed nations built their wealth using fossil fuels for centuries. So the editorial suggests a reasonable approach. Developed nations should invest heavily in carbon dioxide removal, CDR, to clean up their historical mess.
Actively remove their past emissions.
Yes. And doing that would give developing nations the breathing room, the carbon space, to develop their own resources responsibly as they transition towards a low-carbon future on their own terms and timeline.
A phased, equitable approach based on historical contribution and current development needs.
That's the essence of it. Justice and equity are key.
Wow. This deep dive really hammered home that decarbonization isn't just about CO2. It's, like the editorial said, a large dimensional space.
Absolutely. Finding those just and equitable paths means juggling cutting-edge tech, global politics, economics, inflation, and those fundamental human needs covered by the SDGs: food, water, health, poverty.
And things beyond just climate, like energy security, resilience to shocks. Thinking about COVID, wars, climate disasters like Hurricane Katrina, which cost a fortune.
All interconnected. Minimizing that carbon inflation for the transition costs and the climate inflation from inaction, while investing smartly in innovation and renewables, it's a monumental task.
It really is. So considering this immense complexity, the tech, the economics, the geopolitics, the equity issues, What does really understanding all this mean for how you, our listener, view the global energy future? And maybe even your own role, however small, in shaping it. It certainly gives you a lot to think about.
It definitely does. It challenges easy answers.
Well, this has been incredibly insightful. Thank you so much for joining me today and helping us navigate such critical, complex subject matter.
My pleasure. It's vital stuff to discuss.
Indeed. Goodbye for now.